Okay, yeah. So again, investigating the pH scale. Just again, I wanted to just point out a couple things. H3O plus, that's the same as H plus. We call this H3O plus. We call this the hydronium ion. Oh, it's there already. Ha, H3O plus. The H3O plus is the hydronium ion because actually when we have H plus in water, when we have an aqueous solution, it actually attaches itself to a water molecule. So it doesn't actually exist as H plus in water. It actually exists as this H3O plus as the hydronium ion. So you could see it written either way, H3O plus or H plus. They're both the same thing. Okay, they're both the same thing. It's just a matter of how you look at it. Okay, and remember that if we have an H plus is the same thing as a proton. It's just the proton. So basically, this is water with an extra proton attached to it. Okay. So we're looking at the pH scale of a bunch of different substances. Uh, Basically, anything that is less than 7 is going to be an acid. Anything greater than 7 is going to be a base. Okay. Um, you'll notice that if something's basic, the hydronium ion concentration is very low, okay, whereas the hydroxide ion concentration is very high. One of the things to remember also is that the hydroxide and hydronium ion concentrations, they're never zero. They're never zero. Even in a super basic substance like drain cleaner, which has a pH of 13, you still have some H3O plus. You still have some H3O plus. Okay. And even something very acidic like battery acid. Okay, you have a lot of H3O plus, you have a lot of hydronium ion, but you're still going to have some OH minus. It's a very, very small amount. It's a really, really small amount, but you're still going to have some of it. Okay, and this is because of the auto ionization of water. So auto ionization of water is this idea that water will break apart. So it'll break apart into H plus or H3O plus and OH minus just naturally. Okay. So auto ionizes itself. It just that's what it does. Okay. So in water, some of it's H3O plus and some of it's OH minus. Okay. And the ratio of them, it's always if you multiply H3O plus times OH minus, no matter what solution you're looking at, you multiply them together, they will always equal 1 times 10 to the negative 14th. And we call that the auto ionization constant of water. 1 times 10 to the negative 14th is the Kw, or the auto ionization constant of water. Okay. So it's always the same. That's where we get this relationship H0 plus and OH minus equals this. It's just always that way. Okay. Okay, you'll see that if you have a low pH, so the H3O plus goes up, and if you have a high pH, then sorry, and if you have a low pH as well, the OH minus goes down, right? So acidic H3O plus goes up, OH minus goes down, and then the opposite is true for basic solutions. H3O plus goes down, OH minus goes up. Okay, so you should have seen that. If their H plus and OH minus concentrations are equal, okay, then it's neutral. Okay, but this should say not equals, but times. So H plus times OH minus should always equal 1 times 10 to the negative 14. Okay, then this other stuff. Let's see here. Let's see if there's anything you want to go over. So it did a little bit of a titration here. Remember, titration, you're adding either acid to base or base to acid. Okay, so different substances like drain cleaner starts out very basic, right? And actually this one we're just adding more to it. So you're adding more to it. It's getting more basic. This one's getting more basic. It's just going to get either more basic or more acidic depending on what it is, right? I think this one I may have made a mistake on this one, but I'll fix that one. Okay, let's see here. If we're diluting it, so this one we're diluting it, we're starting with drain cleaner and then we're adding water to it. As we dilute it, we're gonna make it more and more neutral. Water doesn't necessarily neutralize it, it's just going to dilute it. Just gonna dilute it. So it's gonna lower the pH for a base, it's gonna increase the pH for an acid. Okay. Oh yeah, that's right. This one's right. I just realized that this is acidic, so it's going to go down. Yeah, that's right. Yeah, so this one, the acid goes up, bases go down when you're adding water. You're basically just diluting it, getting it closer to the middle, right? The 7 point. So if you add water to a base, it's going to go down. If you add water to an acid, it's going to go up. They're all trying to get to that neutral point. Okay. Okay, and the last part here, determining pH. So remember that pH, if you want to find the H plus concentration, it's 10 to the negative pH, and you'll get the H3O plus concentration. Okay, and then you take the log of that, you get the pH. Just showing that relationship there. Really, all this last part was showing all the relationship between pH, pOH, OH minus, and H plus concentrations. Okay, and all those relationships are down at the bottom here. These are all the ones you really need to know here. So H plus times OH minus gives 1 times 10 to the negative 14. Negative log of OH minus is POH. Negative log of H plus is pH. And pH plus POH will always equal 14. Okay. So knowing all these relationships, you should be able to convert between any of the four. Okay. Okay, so hopefully you did that and you kind of understood what was going on there. I did post the answers last night, so now the answers are there if you want to check it out. Okay. Does anyone have any questions on that work from yesterday? No. Okay. Okay. So the assignment for today, I'm going to go over talk a little bit about equilibrium, what equilibrium is. Okay. And then your assignment is to go through this polo activity. It's kind of guided, so you just kind of read the questions and answer it as you go. I did post the answers here. So do try it on your own first, and then do the answers afterwards. Okay. And I helped you out a little bit. I did some of the work for you already in the worksheet. And let's see, it's taking forever to load, but it's getting there. So the last topic we got to talk about in this unit is equilibrium. Usually, so acids and bases are a pretty big topic, but we kind of just we just go over the very basics of it right now. That's all we really do is just the basics. Okay, there's a lot more to it than that, but this is all you really need to know for now. I do want to talk a little bit about equilibrium before the course is over. It's an important topic, and at least to give you an introduction to it and understand what equilibrium is before you leave me. So if you do take a course in the future, you understand what equilibrium is. Basically, equilibrium is so all the reactions we've been studying up to this point, they're going in one direction. Okay, you go from reactants to products. Okay, however, most reactions actually don't do that, just go straight from reactants to products and then the reaction stops. What actually happens is some of the reactants go to products, and then some products go back to reactants. The reactions kind of go in two directions. Okay, they're kind of reversible. Okay, so these are some examples of equilibrium. So H2 plus I2 yields 2HI. So basically H2 and I2 are coming together and forming 2HI. But sometimes those HIs will split apart into H2 and I2. So they go back back and forth. It's kind of like, yeah, it just goes back and forth. It's like tennis, right? It's like tennis, back and forth, back and forth. All right, now that doesn't mean that all of the reactants go to products and all products go to reactants. What we have is every equilibrium has a different equilibrium position. Okay, sometimes an equilibrium reaction will have more products than reactants, so there'll be a lot more HI here than H2 and I2. And other times there's going to be a lot more H2 and I2 than HI. It all depends on how the equilibrium lies, and it's different for every reaction. Okay. So a reaction, if it just starts with H2 and I2, we don't have any HI to begin with. What will happen is those H2 and I2, they'll react and they'll start forming HI. And they'll react, form HI, form HI, form HI. As they're forming HI, some of the HI will go back to H2 and I2. Okay. Now, when a reaction reaches equilibrium, the rate at which the reactants turn to products and products turn to reactants are equal. So there's still going to be some products going to reactants, some reactants going to products. Okay, but the overall rate of the front and the forward and the reverse reactions are equal. So the overall concentration of H2 and I2 doesn't change, and the overall concentration of HI doesn't change. The overall concentration eventually stays the same, stays constant, even though they're still going back and forth, back and forth, back and forth. They're going back and forth at the same rate. So overall, there's no change in concentration of either reactants or products. And that's basically, once it reaches equilibrium, that's what it is. Okay, so that's what I'm talking about here. So you have H2 plus I2 yields 2 HI. At first, the forward reaction is very fast because we start with just H2 and I2. They're forming HI. Okay. And then as HI forms, that reaction, the HI to H2 plus HI2, the reaction rate increases. And these two reactions, the forward reaction decreases, the reverse reaction increases until we get to a point where the forward and the reverse reaction are equal. They're moving in at equal rates. Okay, and that is when we get to the equilibrium state. Okay, the equilibrium state, where the reaction rates are equal. It doesn't mean necessarily that the concentrations are equal. So this graph over here shows that we don't necessarily have to have the concentrations of products and the concentration of reactants equal. They don't have to be equal. Okay, it's just that they have to be steady. At some point, they just get steady. Sometimes, so in this reaction, we have more products than reactants. So we would say that this reaction favors products. If there's more reactants than products, we would say it favors reactants. Okay. Okay, we're not going to talk about equilibrium expressions today. We're going to talk about that tomorrow. Okay, but basically, this is the principle that I want you to try and understand today. And we're going to be looking at this POGIL activity that you're doing. This POGIL activity should help you kind of get that idea straight in your head here. Okay. I did post the answers for this, so just give it your best shot. For number 6, so number 6 starts the mathematics portion of it. So it says here, let me make this a little bigger. So it says here, consider an initial concentration of 5 moles of A and 0 moles of B. So for this reaction, you start with 5 moles of A, 0 moles of B. Okay. Now this reaction, 60% of the available A becomes B each minute. Okay, so that means that 60% of this 5 moles becomes B. So 60% of 5, you do 0.6 times 5, because 60%, 60 divided by 100 is 0.6. So 0.6 times 5, and you should get 3. So minus 3. So every minute, 3. It's not necessarily that 3 moles will go to B. It's that 60% will go to B. So in the first minute, 3 moles will go, right? 3, and then 3 will become B, so you'll get 3 and 2. Okay. So 60%, 0.6 times 5 is 3. So 3 is going to move from A to B. So it's just a 1-to-1 ratio here. All of these are 1-to-1 ratios, so you don't have to worry about that. But okay. And then over time, so if you look here, if we start with 2 moles of B, right, and let's say 20% of B goes to A, right? So that means, again, 60% of A goes to B, so it's 3 and 3. And then 20% of B goes to A, so 0.2 times 2 is 0.4. Okay, so yeah, where the forward reaction is causing A to go to B, but the backwards reaction is causing B to go to A. Okay, and then if we add these up, we'll get the resultant. So 5 minus 3 is 2, plus 4 is 2.4. Okay. This one is 2 plus 3 is 5, minus 0.4 is 4.6. Okay, so after a minute, those are the concentrations of A and B, or not concentration, the amount of A and B. Okay. And you're going to do that for the next step. You're going to do it for all, if you start with 10 moles of A, 0 moles of B, you're going to do if A goes to B at a rate of 60% per minute, and B goes to A at 20% per minute. You're going to fill in all these charts here. Okay, and what you'll see, so I'll just pull up the answers just to show you, but do try it on your own, and then don't just copy the answers. But what you should see is that A goes to B, B goes to A goes to B, B goes to A, and over time, the amount of A going to B and the amount of B going to A gets smaller and smaller and smaller. It gets smaller and smaller until the amount of A and going to B and B going to A are equal to one another. Okay, so the rate of the forward equals the rate of the reverse. Okay, and you should see that in the work here. Okay, eventually, the amount of A going to B and B going to A becomes 1.5, and it doesn't change. It just stays that way. 1.5, 1.5, 1.5, both ways. So the rate of the reaction just is constant in both directions. Okay, and when that happens, it's reached equilibrium, and then you'll figure out how to do the rest of that there. Right? Okay, so give that a shot. Okay, take your time on it. Go through it. Again, I gave you the answers, so if you do get stuck and get frustrated, feel free to look at the answers, but try and do it on your own first. Okay.